Let's study effectively with Miss ICT Skill Builder. Every sound you hear and every sight you see is analog, but your computer only speaks in numbers. In this session, we're bridging that gap. We'll explore the core differences between analog and digital data and show you exactly how our devices translate the real world into a language they can understand.
You know, we live in this world that's full of, well, stuff. Sound, light, texture. But our computers, they only get numbers. So how in the world do we bridge that gap? How does our rich analog world get translated into the simple digital language of our machines? Well, that's the fascinating story we're going to dive into. Seriously, have you ever really stopped to wonder about that? You record a quick voice memo or you hop on a video call. How does your voice, this invisible thing, actually get inside a computer and become a file? It's kind of a mind-bending question when you stop and think about it. Okay, so at the core of all this, you've got two totally different worlds. There's our world, the physical one we live in, and then there's the world inside our computers. And the big problem? They speak completely different languages. And this really lays out that language barrier perfectly. On one side, you've got analog. Just think of it like a smooth, continuous wave, like sound. But on the other side, you've got digital. And that's all about separate individual pieces of info, just zeros and ones. And this right here, this is the entire universe for a computer. Seriously. For a machine, everything, and I mean everything, boils down to a huge number of tiny little switches that are either off, which is a 0, or on, which is a 1. That's it. That is the whole language it knows. So before we can even think about building that bridge, let's get our really good handle on the language of our world. What does analog actually mean? Here you go. This is analog data out in the wild. The sound waves from your voice, from a song you're listening to, all the sounds around us. That's all analog. It's that constant, uninterrupted flow of information that our ears and eyes are built to understand. And the key word here, the one to really remember, is continuous. See, an analog signal isn't chopped up into little bits. It just flows smoothly, kind of like a ramp. It can have any value along the way, with no breaks, no sudden jumps at all. All right, let's hop over to the other side of the fence. How on earth do computers take our super complex world and represent it with such a ridiculously simple system? It all comes down to one thing: binary. A computer's language basically has just two words: on, which is a 1, and off, which is a 0. That's it. A 1 means there's a pulse of electricity, a 0 means there isn't. But by stringing together billions of these on and off signals, computers can build up to something incredibly complex. And each one of those individual zeros or ones has a name. It's called a bit, which is short for binary digit. This is the absolute tiniest piece of data a computer can work with. You can think of it like an atom, the fundamental building block of the digital world. Now, when you group 8 of these little bits together, you get what's called a byte. And bytes, well, bytes are where the action is. A single letter on your screen, like the letter A, that's usually 1 byte. An entire song file, we're talking millions of bytes. This is exactly how we build up all that complexity from something so simple. Okay, so now we get it. We've got our two languages, the smooth analog wave and the choppy digital code. So this brings us to the main event. How do we actually do the translation? How does a sound wave turn into a long string of ones and zeros? And let's be clear, this process isn't just oh, nice to have. It's absolutely essential. If we want a computer to do anything at all with a sound, save it, change it, send it, we have to convert it first. We have to digitize it. So here's how it works. It's basically a 3-step process. First up, A microphone acts kind of like a mechanical ear, right? It captures the real physical sound wave. Then a program starts sampling that wave. And what that means is it takes thousands of little snapshots of the wave every single second. And finally, it takes each one of those snapshots and assigns it a binary value, a number made of, you guessed it, zeros and ones.
So what you end up with is, well, it's not a perfectly smooth ramp anymore. The computer rebuilds that sound wave as a series of really tiny steps, almost like a staircase. But here's the magic. If you take enough of those snapshots, thousands every second, that staircase becomes so incredibly fine that to our ears it sounds almost identical to the original smooth ramp. It's a really, really good approximation.
And this is where things get really cool. So our voice has been translated, it's now digital. What can we actually do with it now? What kind of superpowers does this give us? Ugh, the possibilities are just mind-blowing. That digital file of your voice, you can store it on a hard drive pretty much forever. You can share
Thanks for watching. If this helped you clear up the concept, hit that like button and share it with a friend who might be struggling with it too. Let's build those skills together.